Hello, everyone. We are back again. My name is Pat. We also have Dave from Simply Subarus. If you know, this is Subaru Mechanics, and this is the Wave Podcast. Basically, we're here today with a great guest. We have Neeraj, and he is going to walk us through how to 3D print a EJ engine. Yeah. I felt like I had to do that. Dave, I got some news for you, buddy. I had a very bad week this week because something happened to my Subaru, and I just want to show you what went down. Pull it up here. Oh, it pains me to even look at this right now. So, in my garage, this happened. In my garage. So I'm like, it's Saturday. I'm home. I'm like getting in the Subaru. I'm going out to lunch. I got a buddy in town, my wife's with me. And we go out to lunch and we go to get in the car. And my wife goes, "What happened to the Subaru?" And I'm like, "What do you mean?" And I took out the taillight, the bumper, and the quarter panel. So
Yeah.
we go home. I start putting the pieces together. There's shrapnel and paint on the ground in the garage. And I'm like, okay, it had to have happened here. So then I'm like, what possibly could have done this? Right? And then I find that this matches up perfectly to the crime.
Oh, no.
So I don't know what happened, but somehow this rake fell and took out the quarter of my car, and so I'm just like, how? And how did nobody notice a rake in my garage just on the ground? So now I'm trying not to go on a witch hunt, but now I'm like, what happened?
Luckily that the quarter panel it'll have to be touched up and everything, but that won't have to be replaced.
Yeah.
The bumper, depending on the depth of the scratches, might be salvageable, but worst case scenario, it can be replaced a lot easier than a quarter panel.
So I got a quote, $1,500.
Sounds about right.
And you know what's crazy? The thing about this quote that I don't understand is that they're quoting me to remove the roof rack and to pull my headliner. So I don't.
That doesn't add up.
It says for access, but access to what? Like, is it the sensors or something? I don't know. So whatever. So I'm just whatever. I'm frustrated with it.
My alarm bells are ringing again. I'm very sorry to see this. It reminds me of unfortunately years ago, my grandfather had a 75 Ford Maverick, which I'm proud to now own. And I remember going to visit him one summer, and I would go into the garage, and sure enough, there was the Ford Maverick, which I remember telling him as a child. I was like, "Grandpa, I don't want any money. I don't want anything else in inheritance, but I want the Ford Maverick."
Yeah.
And sure enough, I go in the garage, and his golf clubs are just leaning up against the side of this thing and just scratching the rear quarter to holy hell. And I'm just like, okay, calm down, keep it cool. But I had to go up and have a couple words with my grandfather, rest in peace, back at the time. And I was like, "Grandpa, what are you doing? This is a classic. You don't just leave." He's like, "Well, they must have fell over. I mean, I'm not too worried about it. Still runs and drives."
Yeah. Oh,
and he's right. But I humbly, now inheriting the vehicle proudly. I'm fully working on restoring it bit by bit. And the one thing I want to actually have uh, uh, preserved is the word, is those scratches. I know it sounds kind of ridiculous now, but I plan to effectively clear coat over those scratches and preserve those because I feel like they're a memento of my grandfather and that kind of that moment where I chewed him out because he had his golf clubs leaning up against the side of this thing, and I was like, "Who does that as a car guy?" Like, but then again, he wasn't really a car enthusiast to a sense, and he was just more, utilitarian, and that was just a different time, I guess.
Yeah. I mean, it's not a good thing. It just doesn't feel good when it happens. I had a old Tiburon that it needed a clutch job, and I got it towed to my house. And I remember I told my mom I had two Tiburons. One was a parts car, and I was like, when it rolls down off of the tow truck, I was like, it's not gonna stop, so it's gonna come down slow. I was like, just stop it if it's gonna keep going and hit my car. And she took a step back and just watched the collision happen, and I saw both bumpers just get obliterated, and I was like, this is it. This is it for me. I've had it.
Those
uh,
are I call those the profound moments. Uh, Not to cut you off, but I feel like that instill you being a true automotive enthusiast is when you can withstand those gut punches, those really deep cuts where you're just like you witness something that is just horrible.
yeah,
And it might not seem horrible to the average person, but it's horrible to you,
yeah,
rightfully
yeah.
so.
For our younger kids out there, I promise you, you take enough hits, eventually it gets better. You just stop caring. It's like in the beginning, it's like the worst shot ever, and then it's like it starts to get better. So, Niraj,
So
I've
true.
never
Very
had
true.
any accidents or anything like that, but it's not a good feeling.
No.
Um, so we're gonna dive right in with Neeraj. Um, this is one of those really cool topics that kind of popped into my lap. I love when Facebook recommends me a group that I have never been in. I have no connection to it, but of course it's Subaru related, so it's in my algorithm and it pops up, and I'm immediately like blown away by the topic. And basically, I was sitting down, scrolling through Facebook, and this popped up. And I saw this post that Niraj had put out, and it just was so amazing to me because it was so in depth. It had so much thought put into it, and the concept of 3D printing an EJ engine was just so out there. And I know that people have recreated plastic versions like these toys and stuff, but like nobody has ever talked about trying to really 3D print a running engine. And so like this was just like such a cool concept, and as you can see it got a lot of people excited about it. So um I just thought it was a really cool thing, and I wanted to get you on to kind of run through it. So I think where I kind of want to start is I just want to talk to you about your background in automotive engineering, 3D printing, what kind of experience you have in the whole field.
Yeah, that sounds great. Well, first of all, thanks Patrick and Dave for having me on. This is a lot of fun getting to know you guys. Yeah, so to start off, my name is Neeraj. I'm 24 years old and I'm from Toronto, Ontario, Canada. So land of
Nice.
the north,
another
home of the free.
another Canadian on the podcast.
Another Canadian, that's right. So in terms of schooling, I just recently graduated from McMaster University, which is up here in Canada. I did my bachelor's of engineering and I specialized in mechatronics. So that's just mechanical
Wow.
electronics.
Yeah.
So, and then this September, I'm starting my master's in aerospace engineering at the University of Toronto. So
Awesome.
that would be lots of fun.
That's awesome.
Yeah.
Dude.
So
You're a
first
man
of
who
all,
takes on the challenge, right?
yeah, I'm not one to shy away.
Yeah.
People that know me definitely know that. So, yeah, in terms of my background with automotive engineering, I've been building things all my life. That's kind of how I kept myself sane. Whether it was solar panels, 3D printers, guitars, whatever it was. I was always making something, but I went off to university, and interestingly enough, we didn't have as many engineering projects that I thought we would. So I needed something to really sink my teeth into, get me excited. So at age 19, I decided I was going to build a kit car. So I decided to build a Factory 5 818 kit car.
Awesome.
Factory 5 is mostly known for their Cobra replicas and such, but in this case, it's an original design, and it accepts Subaru running gear.
Amazing.
So that's how I got into Subarus. And actually, what's interesting is when I decided to build that thing, I actually had no automotive experience. So I had never even changed the oil on a car.
And this is that car, right?
That is that car. That's what it looks like right now.
Wow, man.
Yeah, it's getting there.
Amazing.
It's been a few years. Really, it's just so many tiny projects is really what it is to make this one big one.
Yeah.
Yeah.
For anybody listening at home, he's got a picture of his red kit car. It's got a roof scoop. It's got triple gauges. It's got the whole package for any kind of sports car. It looks almost like an MR2 body. And
Interestingly enough, you say that the glass from an MR.
That makes sense.
Interesting. Wow. Okay.
Yeah.
And I appreciate that a lot about kit cars, where they kind of incorporate, usability of like, well, if we make this back window some proprietary thing that you have to get from a certain manufacturer, that then again, unfortunately, let's say 20 years, 50 years later, they go out of business. Now you're screwed.
Yeah.
And I think that's a smart bet, I feel like, of a lot of these kit cars, is they're incorporating so much of the different OE levels of things,
And
I definitely agree.
what kind of wheels you got on there?
Oh, just some Chinese.
They look good though.
They look good, don't they? But you know what? The car is so light. I just figured, yeah. And plus, I'm on a bit of a budget too. This thing just climbs and climbs in price. It could just go to the sky.
Don't they all?
Yeah.
Yep. I'll give you just like a 30-second rundown of this thing, and then we can move on. But it's mid-engine, rear-wheel drive. It's just an STI motor. It's an EJ 207 in the back.
Okay.
And it's got the 5-speed. It's cable shift now. So I've run cables from the transmission all the way through.
Interesting. Okay.
Yep.
That's awesome.
And no traction control, no ABS, no power steering, no power brakes, no airbag.
Don't need it.
Nothing. Just the bare necessities. Pure analog. It's a lot of fun.
This
thing is beautiful, though, man. This thing is fantastic. I bet it's a ton of fun to drive.
It is very scary to drive.
I loved it, man. Such a cool project. I mean, it's just awesome when you get to build something from the ground up like that, and like see it start to come together, And I mean, dude, if you're going to school for your master's program, you roll up in this, that's gonna be like this statement. They're gonna be like, "You built this?" You're like, "Yeah."
I think it'll definitely capture the interest of a lot of people. Yep, for sure.
And if you don't mind me asking, I'm just curious, at what point, to Patrick's comment there, at what point did you kind of feel like, okay, you kind of see the vision? I'm just curious, out of, as you were assembling this, was it, the frame and engine going in, or was it the body going on? Like, I'm just curious where you kind of felt that, like, not sense of completion, because with any project, it's never complete, right? But I'm just curious where you kind of felt like you really saw things kind of coming together.
Yeah, that's a good question. So really there was stages to this thing, right? I mean, the first sort of stage is just that bare tube frame chassis, You throw the engine in, you get all the suspension working, and you take it out for a drive. In go-kart mode, is what we call it, right?
Oh my God.
Just pop a
That's
seat in there and
incredible.
just, you just got this sort of dune buggy looking thing.
You're like,
And
it's
I took it out.
working, right?
Exactly. That's sort of the proof of concept. I took it to the park
Okay.
just behind my house and did some donuts in the baseball diamond.
Wow. Wow.
Yeah. And I was like, okay, you know what? This thing, it moves. But you're right. Once I got the body on, I started on body work, which took a while, and it's still not done. But once I got that body on, it's like, okay, this thing looks like a car now.
It's a car.
And
Okay.
yeah. And then once I did the interior all up nice, that's when I was like, okay, this is something I'd actually just like to sit in. And I sometimes just sit in there and grab my laptop and do some work.
So
Man, that's beautiful. The way you say that, like that's
yeah,
it's an automotive enthusiast journey. I feel like it's a journey because, as I said, I'm sure it's not done, right? It's never done.
Yeah, it's a good point. It's never done, but in this case, I'm hoping that it's like drivable. I mean, it is drivable, but properly drivable quite soon.
Mhm.
It's interesting. It will be street legal, so
nice.
there's some hoops I had to jump through to get that, but I've got a registration for it now, and insurance is its whole own can of worms as well.
Yeah. The one thing about this that's catching my eye that is like throwing me is it has 4 hood pins. It's
Yeah.
got two by the windshield and 2 by the headlights.
I didn't even notice that.
So
Yeah, you're right.
you just pop the whole thing.
Yeah,
That's
you
awesome.
just have to lift the whole thing off. I mean, it's so light. It's all fiberglass, right?
That's a mechanic's dream.
Yes, it is.
Yeah.
Although there's not much in the front anyways. There's just, radiator, battery, speaker amplifiers, AC compressor, etc.
Sure.
Yeah.
So you're not doing too much work. In the back, it's got a proper hinge to lift the glass and everything, so you can work on it.
That's awesome.
I feel like every mechanic just wishes every body panel came off like that with with pins.
Yeah. That's the great thing about this thing is I can make it as serviceable as I want it to. Really.
Yeah.
Yeah.
This is really cool, man. I really appreciate you sharing that. I think that going into this episode, I was very excited because the pictures you sent just kind of blew my mind, and like this project as a whole is something that I always thought should be possible, and I just feel like you're the guy. I hope I'm praying because I would love to have you back on down the road and be able to like talk about it like functionally in a car, But so, what I kind of wanted to talk a little bit about is like how did you get here? How did you end up with the EJ as the block you were going to build? What kind of drove you to go and try this project, and like, what is your outcome that you're looking for to get out of this thing?
Okay, so that's definitely a good question. I can start off with after this sort of kit car started nearing completion, I got a lot more Subarus. So I got a Forester, I got a Baja, I got an STI. So I had just tons of Subaru parts lying around.
You got the bug.
Yes, I did. I got the bug, It's a problem, isn't it? Yeah, just my garage. I'm lucky I had nice parents. They've let me take over the garage for the past few years. And it's just full of Subaru parts.
That's awesome.
So I think the natural sort of progression was to continue with Subarus. And that's because I'm really passionate about them. I truly believe that they're a really unique and cool platform, especially from an engineering perspective. They're easy to work on. I just love them. So, but anyways, in terms of 3D printing an engine, I made a 3D printer when I was in sort of middle school, high school-ish. And that's kind of when I caught that 3D printing bug.
Yeah.
So it just kind of grew from there. I 3D printed I 3D printed some guitars. And that kind of made me realize that this, 3D printing's got some structural purpose, right?
Yeah.
So recently, just maybe about a year ago, I built a new printer, which is so much more capable. And after I printed some guitars on it, I was like, I got to use this for something. And now I know a lot of people believe that 3D printing is just for mucking around. It's just for prototypes. It's just for decorational purposes. Like you 3D print something just to fit it, and then you go into the shop and weld it out of steel or something, right?
Yeah.
But my logic here is that if that were the case, then what's the point of all these really strong, exciting, exotic plastics coming out for 3D printers,
Yeah.
right? If it's just
That's
for
a good point.
prototyping, then what's the point?
Everyone would be using cheaper plastic, the cheapest thing they could, right? You're wrong.
Right.
You're not wrong. I get your point.
Yeah.
That's a good point.
Yeah, exactly. There's some really, really interesting developments that have happened in terms of plastics for 3D printers in the past couple of years.
Yeah.
So I thought it's got some structural purpose. And what better way to prove that than an environment that's really stressful on materials, and that's engines, right? I mean, I had Subaru parts. I had just an engine block lying on my desk because I needed space in the garage. So inspiration came from a few places, right? And also, I've always been interested in engine design. I've been really wanting to design my own engine for the past couple of years now. But, designing your own bespoke platform, I don't even think I have the knowledge for that yet. So I thought, let's start
lot of
something
R&D.
that exists. A lot of R&D, yep. And plus, let's say you want to make a cool engine, let's say like a flat 8 or a flat 12. How are you going to get that thing manufactured?
Well, so we did an episode on the Subaru F1 car that had an Italian, what was it, Italian flat 8 in it, or flat 12 or something?
12.
That's Subaru
12.
will make a flat 12. Yeah.
So
It was
is
insane.
possible, but I, the thing I love about this, the part of this that gets me so excited, is that the one thing everyone hears is like when a mechanic's working on something, they're like, why did they design it this way? Why, I wish that it had this or it had that. And like the benefit of 3D printing an engine is you could literally go in and be like, I'm gonna make that change and run it my way. And dude, you could end up with a Subaru meet where every engine is designed completely differently with like small little tweaks, and like it's just like such a amazing idea that like you could take something and just kind of make it your own with your own little things to it. You could even make places to attach things on the outside of the engine. Like you could just make all of these changes, which I think is so cool and like such a cool concept to be able to do that. So
Yeah, I think that's definitely a big part of it for me as well, is to say, hey, like, we can customize this engine to our own each individual likings and needs, and engine accessories, just like you said too. Like, let's say, I need a new oil pump.
yeah.
Let's just print the housing, right? And make it a little wider,
Yeah.
right?
Yeah. That would be awesome. I saw somebody in the comments, maybe it was the post in the Subaru Mechanics group, but they said if you're gonna 3D print an engine, you got to 3D print the TGVs and then delete them.
Oh, the EPA is coming for you, man.
Oh God, yeah.
Yeah.
Don't tell them I drilled those out a long time ago.
Yeah.
Yeah.
So yeah, man. So like, what's the tech specs that you're looking for on this thing? Like, what kind of, like, do you have a horsepower limit that you think that it'll be able to hit? Is there any kind of, issues that you think will come up in trying to get it hot enough to run, anything like that?
Yeah, there's, you know what, there's a lot of issues with trying to do something like this. Really, aluminum doesn't really have a lot of problems when it comes to making an engine work. It just sort of works, right? In terms of this thing, there's just going through the design, I'm just like running into so many roadblocks, right? But I'm getting through it, and what I'm looking at right now is to just have it naturally aspirated at first, right?
Yeah.
Realistically, I think it'll handle boost if other problems don't come up. In the sense that, let's say the temperature is not an issue and creep is not an issue and doesn't fatigue, then I can crank up the boost and see what fails first. But I have a feeling that it'll handle stuff without a problem. But anyways, yes, naturally aspirated at first, and also we're pulling off a lot of weight here.
Yeah.
I went and grabbed my block and I stood on my weight scale. I was like 55 pounds heavier holding that block, right?
Yeah.
So that's a lot of weight we can cut off. And in this case, I'm looking it to be around 15 pounds total for both pace halves.
15 pounds and pushing boost would be, that's so sick.
Yeah, sounds too good to be true.
Yeah, everybody driving an LS right now is like, wait, what?
Right? Like, imagine just being able to like, yep, here's your engine. Just
Yeah, that's crazy, man. You know what? When I first got in contact with you, I wanted to reach out to Teeter Dave, because he does a lot of engine builds. He's got his whole engine shop. And I knew he was going to be like, whoa, what is going on here? Yeah. But you know what's funny? You know who I did talk to this week was Mark from the company 23. And he said that he saw your post in the 3D printing group. And he said that he was blown away by it and he thought it was really cool. So,
wow, that was super cool.
Yeah, he reached out to me. It was funny. I was like, yep, he's coming on. Don't worry about it.
Yeah, you'll hear all about it.
Yeah. So, yeah, man. So let's just kind of walk through this thing. What kind of material are you using? What files, are you using CAD? What is the process of trying to make this work?
Okay. So, first of all, I use Autodesk Inventor for everything that I do. It's just modeling software. No particular reason other than that's what I used in school and at my previous job. So it's commonly used in industry. Now, the limitation with Autodesk Inventor is that you can't model threads. So anytime you add a thread to any part of your model and you export that as like an STL or just, a 3D model file, the threads are gone. So, but you know what? In this case, there's not going to be any threads on the block anyways, and I can get more into that later. But yeah, so Autodesk Inventor, and I designed the whole thing myself. So I was able to find a 3D scan of an EJ engine, and a lot of people were asking me like, "Hey, why don't you just 3D scan this thing?" And there you go, Bob's your uncle, right? But there's a lot of problems with that. First of all, the resolution of your 3D scan might not be high enough to give you any dimensional accuracy, right? It'll give you the overall shape. It's not going to give you much more than that unless you have a decently high resolution 3D scanner. And in addition to that, you have to do a lot of feature recognition. It's a lot of work.
Yeah.
And you know what? I was designing this from the ground up to be out of plastic anyways. So what I did, which is kind of an interesting idea, was I took the block and I went down to my printer scanner and I just put the block on the scanner. Like just a normal, just hoping the glass wouldn't break, just flatbed scanner and scanned it. I scanned the sides at least that I could. And from that, I was able to get sort of the outside contours, some critical dimensions I was able to get. And then everything else I measured with calipers. Yep. It's definitely took a long time.
I'm just going to put this picture up here because you guys need to see this. This is exactly what he's talking about.
Yeah, it's kind of funny.
So you just threw it on there and hope for the best.
And hope for the best.
That's impressive.
And what's great is that these scanners, they scan like an A4 size sheet of paper. So it's exactly 297 millimeters. So I just pulled that in my modeling software, set the size to that, and all the dimensions are perfectly accurate.
That's amazing.
Yeah. So I think this is kind of slept on, this method.
Yeah. I mean, this is like game changing. It's like insane. That's awesome, dude.
Yeah. I mean, there's still work to be done after, but yeah.
Yeah. I mean, it's true though. Like when you are putting something together and you're trying to get a final product that is really solid and you want it to be exactly what's in your head, right? You got to find a way sometimes, and that's exactly what you did. I mean, it just came out awesome. Um,
Yeah, I think really what I was trying to accomplish there was getting things to work the first time. I mean, that never happens, but you got to try, right?
so
Oh yeah,
is this like
Yeah.
the outcome of that? Like this is the scan?
exactly. Yeah. So that was a scan that I took. That's at the bottom of the engine where the oil pan is, right? Um,
Okay.
you could see at the bottom there is where the oil pickup tube goes. You got all your
Yep.
M6 bolts.
The
So
quality is great. I mean, you can
yeah,
clearly see every hole and everything. It's
yeah.
all
It's interesting at first glance, like when I took the scan, I was like, oh my God, this looks terrible. It's all blurry. But actually, if you zoom in, it's just the parts
It's a
that
lot of
weren't
detail.
touching the glass. Yeah, there's actually a lot of detail. It's plenty for what you need to do here.
oh, I can't do
I
that.
mean, you can see machining marks.
Yeah, exactly. It's
That,
totally
yeah,
great. It
that that
totally worked.
that goes to show you, detail, which again is impressive. And the little that I know with 3D printing, I do have a friend locally who's really into 3D printing, and he has one of those 3D scanners. It's tens of hundreds of dollars, and he's got like a bunch of these little dots. I don't know if you're familiar with this kind of medium, but he had to scan something on a product for me. He's like, "Hey, I'm going to design something, a bracket for you. I'm going to 3D scan it. I'll come by." And he had to put all these little like stickers on it. And I was like, "What are you doing?" He's like, "Oh, they come right off. They're little, stickers." But he put those all over the thing, and that way he could scan it and get the whole dimensional aspect of it, which was really intriguing because he put a couple of them on like corners. So the dot would now kind of bend, but the camera would pick that up and scanner would realize, okay, that's a contour, that's a 90 degree, or a 45-degree bevel, which was really impressive just to see the technology as it's grown.
Yeah, definitely. So the thing with 3D scanning is that, just like you said, sometimes they need a landmark in order to understand where they are sort of in space.
Mm-hmm.
So those stickers are a great way of doing it. Now, there's other types of 3D scanners which sort of generate their own landmarks just by looking at things in the room. But sometimes you still run into an issue where whatever surface you're trying to scan, it's too reflective, or if it's transparent, like it's not going to be able to
Yeah.
work. So they actually have this spray that you can get, and you just spray down your object with that. You take
He
your
had to
scan.
use some of that too. He was
Yeah.
spraying a rear bike rack, basically. It was a rear bike rack. He was like, I'm going to 3D map this bike rack. And I'm like, how the hell are you going to do that? And so he did the dots first, and then he had the spray. You're right. And it was really impressive to get to kind of sit back and watch like what level of technology is being employed. Like it's incredible.
I mean, it's amazing we could do this at home, right?
Yeah. Is this your printer at home?
Yes. So that is the printer I made recently. It's a Boron Trident.
Did you say
Which
you
is,
made?
yeah.
You made this printer? That's
Yep.
amazing.
Yeah. So the thing with the Vorons is that you can't really buy them. It's sort of a community project. It's a team of engineers that made this printer design and just made it available to everybody. So
Right.
you can build your own Voron. You can't really buy one, but yes. Now it's quite a large printer. It's a 350 millimeters printer.
Wow.
That's pretty large in terms of,
Yeah.
like let's
That's
say
really big.
common printers or Bamboo Labs, like they're smaller. So, and this thing, at least mine, is capable of printing some exotic plastics, much to the disagreement of the Voron community. It definitely can do it. Yeah, and it's fast too. It's fast. When it works, this thing's awesome.
And so by exotic plastics, what do you mean?
Okay, yes. So people that are in the 3D printing sort of community, they're familiar with your base level plastics called PLA. I'm pretty sure it stands for polylactic acid. It's corn based. It's easy to print, requires low temperatures, doesn't absorb too much moisture. Um, then we move on to more engineering plastics. So the common engineering plastic people think about is ABS, right? Used in some car interior trim bits here and there and such. I wouldn't consider that exotic. So we can move on stage higher. Now we get to the carbon fiber reinforced plastics, nylons. In this case, this is PPS, which is polyphenylene sulfide. This is a plastic that is used in automotive components. It's commonly used in water pumps housings. PPS, and it's usually reinforced with something, usually glass fiber. In this case, this is carbon fiber. Now, there's a lot of misinformation about what carbon fiber actually does to the plastic. A lot of people think like, oh, it's taking up space in the plastic. A 3D printer lays down layers. They're like, oh, it's got to make the layer adhesion worse. It's got to make it. Carbon fiber is just marketing nonsense. But that is definitely not the case.
Okay.
Yeah, there's a YouTuber called My Tech Fun. He's got a PhD in mechanical engineering, and he does engineering tests that are standardized on 3D printed parts. And he tested specifically this plastic without carbon fiber, with a higher percentage of carbon fiber. And the highest percentage carbon fiber pretty much outperformed the others in essentially every metric.
Wow.
So these carbon fiber reinforced plastics are, yes, exotic, but have very awesome potential. Just to put this in perspective, a 4 millimeter by 4 millimeter cross section, which is like an eighth inch by an eighth inch little tiny hole, was able to hold 90 kilos, so like 200 pounds.
Whoa.
Yeah.
And to your point, my friend locally here that does 3D printing, he was designing that bike rack that I was telling you about. We did, again, a lot of prototypes. There was probably about 12 different prototypes. Just getting the design right, and how things work together and click together and fit. And long and short, we settled exactly on a carbon fiber composite because it added that perfect level of rigidity to where now it's it almost might as well be injection molded, at this point. And that's kind of that groundbreaking level where all of a sudden this can withstand immense amount of shocks. And again, we went through a lot of prototypes, basically not to try to make things as cheap as possible, because it was mainly, for me and a couple friends here locally that wanted this as a community. But we weren't trying to, all go get injection molded, and spend $10,000 or whatever for an injection molded process, where all of a sudden we can now 3D print something, go through a couple iterations, and now really fine tune something that, okay. And we quickly realized with certain plastics, we're like, this doesn't work. It's too brittle, it breaks, it falls off, whatever. So we found that the carbon fiber, you're right, is just that perfect kind of blend, because it does kind of have some flexibility too, which is really important. And people don't understand that. You have to have a little bit of give, and metal does that too.
Yeah, and you know what? When I first got in contact with you, the first thought that came to my brain about this was, I thought that this would work, and I thought that it would work because of the fact that Ocean Gate exists, right? And as much heat as Ocean Gate got, because it was ridiculous, such a ridiculous. I watched the documentary on that, and you're like, you knew from day one these people were not making it out. Like they knew what was going wrong. But the amazing thing is that the entire thing was made of carbon fiber. They had a carbon fiber sleeve that they had pressure tested, and they pressure tested it enough that this thing actually did make it down to the Titanic multiple times to that level. And they would hear cracking and creaking in the tubing, but like,
and that's a problem. consecutively. When you have carbon fiber flexing consecutively to where it's creaking, I'm just gonna tell you, I'm not my inner engineer wants to scream right now. I'm like, that's not okay.
But it's impressive that it was able to make it down that far multiple times. Like, it just goes
Absolutely.
like me being a hockey player, right? Carbon fiber is used in every hockey stick. It has the ability to flex incredibly when you take a shot. Now, every hockey stick I've ever had that's carbon fiber I've broken, but at some point, like, they do hold up, and like in certain use cases, especially in something like an engine, right? I could see that we've advanced enough with this carbon fiber building that like it could potentially run a car. It is such a strong component, and I feel like everybody's like constantly pushing the limits on it. So
yeah. And there's so many different composites, and that's the other kind of like metric where all of a sudden different composites of carbon fiber and different weaves all of a sudden to your voice, Patrick, it's like, the fact that you're hearing stress cracking is less than ideal. And from an engineering standpoint, that is not, I feel like that's prototyping. You're still in the prototyping phase, effectively.
Listen.
And
they ran that thing with a Xbox controller. So listen, it wasn't the most impressive thing ever, but the testing video is what blew me away, because they were pressure testing it in like a small compartment, just making sure that it could take the pressure, and it really did until it went it's like
until
yeah.
And I may be wrong, I think it's called an enclave.
Like enclave,
where they put they pressure test and heat test composites, and they basically just stress them until they explode. Which honestly sounds like a really fun job.
Yeah.
And your job is find the failure point. Okay.
Yeah.
Product testing sounds fun to break it.
Just while we're talking, I'm going to put up the scans that you have here.
Yeah.
So.
Wow.
So, I mean, these are just so cool. So walk me through kind of what we're looking at here, like how this is going to translate into your 3D printed product.
Okay. So what you're looking at is a screenshot from Autodesk Inventor. You can see on the left side, I've got a lot of features that it's taken to make this thing. This is the 3D model, which just gets exported, and you take it into your 3D printing slicing software, slices it into layers, sends it to the printer. And then from there, it makes pretty much an exact replica, which is reasonably dimensionally accurate. So in this case here, what I started with was I scanned the deck surface, so where the head gasket would go. And then, converted that to closed deck, extruded that outwards, made the inside of the crankcase, all the main bearing webs, and then we've got all the outside features of the block. So you can see over there the coolant crossover area, where the NOx sensor mounts, where the AC compressor goes. And everything here is exact based on Subaru, like the Subaru block I have sitting on my desk right now. Mm-hmm. So the water pump, the oil pump, AC compressor, power steering, everything will fit perfectly.
That's awesome.
Yeah.
And with that printer that you built, it's big enough to actually print the whole block, right?
Just barely. It is big enough to print this block. So, and I got a lot of people asking me, why Subaru, right? And that was, obviously I'm a Subaru guy, but that's one of the big reasons, is that the Subaru engine block is split into two case halves. So
it's a good point.
I can make a 4-cylinder, right? Yeah.
Trying to build an LS out of this, you need a really big printer.
Yeah.
It'd be the size of a room, right?
Yeah.
This is.
And now I'm curious. I just have to cut. I hope I'm not cutting ahead, but like, how are you planning to mitigate heat when it comes to, a certain factor? That's I think going to be. I feel like everyone's number one question is heat mitigation, and I have to imagine, of course, there's limitations with 3D printing, likes of which I understand very little of which, but enough of which I would imagine you have to have a sleeve, for the piston. As well as now, I'm really intrigued by a previous comment you just made about it being closed deck, which I could see a pros and cons there. And I'm sure you probably sat there on the fence for probably several weeks, if you will, about if I make it open deck, because now that promotes more coolant flow and helps to mitigate the heat aspect. However, from a power standpoint, and I can see why you want to maybe go closed deck from the start. And so I'm curious to hear your take on why you chose what you chose.
Okay, so this is a very good question. Yeah, heat management is sort of the number one issue that I've run into. So first of all, this plastic kind of dictated the possibility of this working at all. I actually have a piece of it right here. I don't know if you could hear it. I can hold it up to the mic, but I don't know if you can hear that.
Sounds like metal.
Sounds like metal,
Yeah.
right? This stuff is just so amazing, and it blows my mind every time I print it, just how strong it is.
Yeah.
But really, the characteristic that it's got is excellent temperature resistance. So now what's commonly used is a heat deflection temperature. So the temperature at which the material will start to deform under a certain amount of pressure. So the heat deflection temperature for this material is 250 Celsius at half a megapascal, which is just about 60 psi. So at 60 psi, this will start to deform at 250 Celsius. Now, an engine...
what's that in Fahrenheit? I don't know Celsius.
Oh. You know what? That's 480 Fahrenheit.
Okay.
Well, okay, that's hot.
You're well above what a Subaru is going to be doing unless it's on fire. So
correct. Yes, that is. Now we're experiencing probably more pressure than that when it comes to combustion and other forces going on in the engine. But just to give you an idea, yeah, startup for sure. And just to give you an idea, this is sort of the temperature resilience of the plastic. Now, one thing that plastics don't do well that aluminum does excellently is thermal transfer. So in a normal Subaru engine, you've got an iron sleeve that's pressed into the aluminum block, right? The aluminum pulls the heat away from the iron sleeve. And I'm pretty sure this is why a lot of manufacturers now go with aluminum blocks, because they pull heat away from the sleeve, and that keeps the combustion chamber cooler, which allows you to run leaner and run into knock less.
Yeah. Facts, aluminum is a better heat dispersion.
100%. Plastic is pretty much useless when it comes
to... compared to steel, though. Aluminum
is steel. Aluminum is amazing. Yeah. You're right. Yeah.
That's why IG has an aluminum pan.
That's right. Yeah. Yeah. It's so plastic's just nowhere close. So pretty much what I have to do is go to a wet sleeve. Now, I'm not sure if you're familiar, but a wet sleeve is pretty much just an iron sleeve. The bottom half of it essentially gets pressed into the block, but the upper half of it that's below the deck is exposed to coolant directly. So you don't need that aluminum there to pull that heat away. You don't have anything there. It's just coolant flowing around.
Yeah.
And so that's kind of the idea here. Now, the problem is Darton does not make a wet sleeve for the Subaru engines. So my weird idea here is to just take a dry sleeve, put some O-rings on it, and just expose it to coolant. and see what happens. I called Darton, and they're like, yeah, I mean, theoretically, yeah. It'll probably rust, but other than that, there's a possibility of this working. Now, what's interesting is that if you flip over to the pictures of the IAG block, you can actually see that there. You can actually see that the edge of the sleeve is actually exposed to coolant there.
Sure.
So
Oh, okay.
I'm just thinking the logic here is down.
Yeah. I mean, honestly, between Dave and I, we probably have enough connects to try to get you the sleeve that you're looking for.
I was just gonna say, I already know somebody. He told me. I was gonna say, I know somebody that actually could probably build you any configuration of, like, if you have dimensions. Yeah, I know a place here, and ironically, they're my neighbors across from my shop. They do precision, like, aerospace grade machining, and that's all they do. And really great. I would say really great neighbors, because every time they come over with one of the race cars, are like, hey, we're driving this thing out to go do some racing, here in Colorado. Love to have some AC on the way out. Can you recharge us? I'm like, I got you guys. And I've never charged them anything. So shamelessly, they owe us a couple favors in a good way. And if you need a couple sleeves machined, just get with me on email after this, and we'll talk, man.
Listen,
I'll definitely be getting in contact with you, Dave.
Also, I love I love telling Mark from Company 23 that I'm throwing his name out there, because I always contact him. I'm like, what are you guys up to? Like, you guys want to make something? Yeah. But yeah, man.
Yeah, we know machiners.
Amazing.
Thankfully, our group has enough awesome sponsors that we're like deeply rooted in the community, and we have a lot of people that back us. And I was gonna say, dude, I'm sure somebody can get this done. But I mean, the concept is sound. Honestly, I get what you're saying. Like, as far as the heat dispersion, like, that is a true answer to that issue. So, I think that's a really cool concept, and I would love to see that come into fruition.
Yeah, and it's great that you're mentioning all your sponsors, because actually this is one thing that I have none of. Like, really, nobody really knew about this engine block idea until I posted it on Facebook. I have no sponsors. It's just self-funded. It's my own idea here.
What we do now, we're gonna find a way to make this happen, man. Well, this has to happen. And humbly, I really want to be. Hopefully, you'll be posting updates for everyone. Because I would humbly love to be there, and I'm sure Patrick probably would too. We'll have to discuss this. Maybe we could be there for the first fire up of this thing. Well, that would be pretty legendary.
100%. I'm bringing the camera. I'll be there. But
dude, amazing.
But dude, I was gonna say, this is something I could see Teeter Automotive getting on board with, right? Because they have
100%.
They have great social media output. They love trying different things. They dabble, dude. They're a full workshop. They have the engine shop. They do installs. They do tuning in-house. You could literally, if you printed this, you could get it there. They would hone it or whatever they got to do to put this thing together. They would put it in the car, put it on the dyno. They would run it. They would be able to do this. And right now, he's already rebuilding his Subaru that caught on fire, and he just put out the post this week that he's got 2 turbos in both the headlights. So
Fred was stoked about our Baja with our canola oil, and trust me, it doesn't even hold a candle to this thing, man. I'm equally excited about this, and I guarantee you Trenton is equally excited about this, because this is groundbreaking. And not to say this is going to be where Subaru is going to be 3D printing their engines, for the future. I don't believe that's your goal intention here either. It's rather it's a proof of concept. It's going, what can we see about potential and further, futuring to where there's a lot of 3D printing, I'm sure you already know, that is being done in metal. There's different mediums where they're using lasers in a metal shaving, bath basically, or a big, tub of metal shavings. The laser comes through and just melts everything together in exactly what you want. And the level of control and precision that you have with 3D printing is genuinely, it's mold breaking, where you can actually, to my point earlier about my friend 3D printing a rack, okay, the first iterations were just proof of concepts. They were very much intended to be broken apart. Like you could, hit them with your hand, they would fall apart. But they were designed to be a proof of concept, make sure things fit together. And then, all right, everything fits together. All right, now we make this thing out of carbon fiber and nylon or whatever, and now the thing can withstand, even the last iteration of the prototyping. One of my buddies unfortunately crashed his bike with this rack on, and it broke off. And we all kind of took stock of it. We're like, well, he did crash, but where could we improve on this?
Yeah.
And we made several improvements now, not only to the material and the structure that we did it, and even I'm sure you appreciate the layering. How you do the layering on 3D printing was very, very important. And once we kind of fine-tuned all of that, our last iteration was, I'm not kidding when I say leaps and bounds of improvement, because we really had honed in where we wanted to be and where we were, and going, okay, this is the gap. What do we need to do to get there?
Yeah, for sure. Sometimes it takes a few tries to get it right, but that's the great thing about 3D printing, is that you don't have to wait for something to be machined or something. You can just print the next one, change something, print the next one, right?
Yeah.
Like,
And especially in the early iterations with the cheaper materials, oh my God, it can cost you pennies on the dollar to do that and just make sure it fits.
Yeah.
And,
plan for this project as well.
My question is, with a material like the one that you're using, how it's like almost metal, if you make a bunch of prototypes and they don't work out, like, can you melt it down, or what do you do with it?
Yeah. Okay. So,
I kind of know the answer to this. Sorry.
You recycle it at the recycling center, like.
you know what? When it comes to this type of plastic, you'd be hard pressed to do anything with it afterwards. Now, there are people that do recycling. Like when it comes to 3D prints, what they'll do is they'll take all the ones made out of the same color and the same type of plastic. They'll crush it up, melt it back down into the filament, the string, and put it straight back into their printer. And you know what? There's so many issues with it. This, a lot of times, this is touted as an eco-friendly hobby. In this States, maybe not as much.
Yeah.
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 But comparative to you doing this all R&D with metal, not even close.
Not even close. Compared to
Not
a
even
company or compared to an industry manufacturing anything, me just printing some plastic in my basement, like it's.
Well, and further elevating your point, I'm sorry, but is to the level where manufacturers are utilizing this technology for the exact reason that we're talking about. It's like, you know what? We just want to R&D some cheap stuff, like not cheap stuff, but like cheap plastic to see if it'll fit. Again, it's proof of concept. And I feel like, not to diminish what we're talking about in this episode, but from an entry gateway point, you have manufacturers using 3D printing to get into R&D on a injection molding level or what have you, on your level now, going, okay, we can actually 3D print some really viable things. I've had my buddy point in case 3D print that rack, 3D print several brackets and different little doodads and things like that for me. And it's been beyond fantastic because the R&D to do that on a previous level would have been exorbitant. It wasn't feasible for us, where all of a sudden now we can undertake something and do something that we would have not been able to do. That is a beautiful, point of the whole 3D printing.
Yeah. And you know what this excites me for is the one thing that's always been a problem is people who try to mate engines and transmissions together. It's like with this, I feel like you could 3D print a plate or something to like make a Subaru engine made up with like a super trans, or you can have the STI 6-speed made up to whatever, like you could really start to 3D print like ways to connect parts that really shouldn't be together, stuff like that.
100%. In fact, I could even design the block to accept a different type of transmission if I wanted it to.
See, that's amazing. I like, Dave.
And that's where, like I said, manufacturers can benefit from that, because it's kind of a plug and play aspect. And okay, again, depending on the median, it's a very, very low cost expenditure to get into R&D, which has always been the biggest hurdle of developing anything, is testing and figuring out, like, does it even fit together? That's the first fit, stage. Well,
yeah.
Let's say you're trying to, design some new handlebars, let's say for a bicycle. Well, do they feel good in this ergonomics?
Yeah.
You could 3D print 20 different variations for very little money. And yeah, are none of them structurally sound, quote unquote, to be production? Sure. But now you're developing something from a very, very cost effective standpoint.
Yeah. Yeah, man. It's a really cool process. I'm like so fascinated by this whole topic. We are gonna just transition a little bit here. So first off, I want to ask you, what is the craziest thing you've ever 3D printed?
Okay. So I actually did post this on that 3D printed car parts Facebook group.
You did.
And everybody hated it pretty much. What I did is you got an aftermarket steering wheel on your Subaru or whatever, right? It takes those 6 bolts. So you need an adapter to convert your spline, which is on the steering column, to those 6 bolts, right? So you buy one from like NRG or Works Bell, right? I bought a couple from Works Bell. Now, I'm not bashing them at all, but they cracked around the spline when torquing the nut down to their spec. So I got kind of annoyed. But what I noticed is that the OEM steering wheel has a little steel insert in that spline to prevent cracking. So I'm like, okay, you know what? I'm going to try something ridiculous. I'm going to cut out the spline and the surrounding aluminum, bolt that into a piece of plastic, and use that to adapt my steering wheel to the steering column. And everybody hated it.
This is amazing.
Amazing. Look at you punching it. It's fine. It's fine, dude.
Actually, I ended up like really reefing on it, ended up bending the steering wheel.
Yeah.
Whoa.
Yeah. Now, a lot of people are told me, oh, you're going to die. You're going to, this is stupid. You're going to die. But you know what? I've done the math. And it's pretty basic calculations, but like nobody can actually tell me that like it's going to fail from an actual numbers perspective. Like nobody can disprove the math. So
you can see the comments. Clearly people were upset by this.
Oh my God.
This is wildly irresponsible.
This looks exactly like the same material that I was telling you about. We finally 3D printed the rack material. the bike
Exactly.
building. Yeah. When I say this stuff, you could hit it with a hammer and it's fine. Like, it's okay.
Yeah, that guy. He's like, actually, you should look at my reply.
Oh, you don't have to drive. You can ride shotgun.
You know, I posted these groups just for fun. Sometimes people have good advice, but in the end, people are always going to be negative. So you just got to take the advice and do what you can with it.
Yeah, I just for anybody listening that's not watching it on YouTube, there's a comment that says, "I don't care what math you put in your paragraph. I ain't driving that car 1 mile with that on there." And Niraj responded, "That's all right. You don't have to drive. You can ride shotgun." Clearly,
Yeah, I think it's
you're pretty active in this group. So
yeah. You know what? That's the post you're looking at right now is that one was more of a joke, I guess. It's that's a 3D printed plastic connecting rod.
Oh,
Again, the idea here is to show that 3D printed parts can have a structural purpose.
yeah.
The connecting rod's like the most stressed part of your engine. I'm not saying this is going to work for any amount of time, but I'm
Yeah.
trying.
just
It's material based, and I think that's where we'll have to connect, because I want to send you my buddy Cody, that's his name, his information, because he's really knowledgeable in 3D printing, and could be a really good resource, for you guys to work together, so to speak, and figure out kind of like pros and cons of different things, because I've gotten with him on multiple occasions, and not just on 3D printing, and just talked about like, hey, I'm trying to design this bracket. What do you think? Blah, blah. And he's like, I think you should add a reinforcement here, or what have you.
Yeah, for sure. I'd love a connection for sure.
Yeah.
I'll keep in contact with you, Dave.
Niraj, I have to say, I used to work for an NHRA driver. We had 3 engines that all made 1,500 horsepower. I used to put the whole engine together. Seeing this 3D printed connecting rod is giving me so much agita. Like I'm literally like, I can't even look at it, because I'm just imagining this thing in an engine like that, and it's just like the scariest thought possible.
The piston goes flying out just immediately.
Just the look of it is really just like
Hey,
throwing.
in the boxer engine configuration, it's not coming back towards you. So
That's right. Yeah, it's gonna hit the car beside me.
yeah, that's their problem, right? They're standing next to your car. Why are they standing next to the car? They should know better.
Known.
Oh, yeah. This is amazing, man. Dude,
I'm really excited about this.
yeah. And so the only thing I was going to say, Niraj, is we were talking a little bit about how this isn't the first time this has been done. Volkswagen, I believe it was Volkswagen, created a poly motor, and that was is that the Volkswagen?
No, Ford actually.
Ford created the poly motor, and you actually sent me a picture of that. I'm going to put that up here. This is a really cool design. So I don't know if you can explain a little bit about what this is, and kind of how. I don't even understand this design, so I don't know if you can walk me through it.
Okay, so Holtzberg designed this engine. It's made of a material called Torlon, which is a polyamide imide. It's safe to say it's an exotic plastic as well, but it has some different properties. There are a couple different types of plastic, but in this case, this one, essentially what you need to know is that it doesn't melt easily. It actually has a higher thermal tolerance than the plastic I'm using.
Oh, wow.
So, yeah. He raced this engine in a Lola at Lime Rock, and it survived. plastic engine block, plastic heads, like
Wow.
plastic pistons. He coated the pistons in, I think he electroplate. I'm not actually exactly sure, but they were coated with something. And it survived. They only had one engine failure,
Wow.
but this thing, it's made of plastic and it worked, right? And now he was planning on taking that further, but it never actually came to fruition. I think that's down to a couple things. One is probably emissions. Plastic doesn't carry heat away well. And number two, there's a lot of design challenges here, right? Actually, I think in 2015, they were planning on doing a newer polyboater and unveiling it. And that actually used PPS parts in it as well. So that's the plastic I'm using, as well as a bunch of different enemies.
This is crazy. A 2.3 liter Pinto engine. It weighed 152 pounds.
That's right.
Versus the steel or the cast iron version, which was 415 pounds. And it made 318 horsepower at 9,200 RPMs. That is like the most insane composed metal cylinder sleeves, metal combustion chambers, metal piston crowns, bearings, valves, seats. This is crazy. And that was the first version. And then I guess they did a version 2 after that. But yeah, I think this is the version 2 that raced at Lime Rock. So, dude, this is incredible. I mean, and this is back in the 80s and the 90s. Like that 1985 was the Lime Rock race. So like, dude, the way that technology has gone, it's not surprising that we're able to actually put something together and run it, you know?
Yeah, there's some precedence here. Like, I'm not the first person to try and make a plastic engine, right? 3D printing a car engine, I haven't seen anybody else do, but this is the proof of concept, I guess.
Yeah.
There's a possibility, clearly.
Yeah.
This would work.
That's just such a cool concept. And they actually have for the 2015 version a breakdown of how much carbon fiber percentage and glass fiber and things like that. So it's really interesting. I think like this could be partially like future engines that we start seeing come out from manufacturers if they do want to step away from like, you know, really diving deep into like the battery and the electric world. You know, I know hydrogen's been on the rise and people are talking about that now, and it's like there's just so many different ways to run a car, and like this is like really a lightweight, just I guess I'll say eco-friendly way. So yeah, man. I mean, it's just so cool that you're gonna be, dude, this is like you're gonna go down in Subaru Hall of Fame as the guy who built and ran a plastic EJ, you know?
The dream.
So that was the other question I had for you. What made you choose an EJ over an FA? Because I saw some people asking about the FA as an option. So
yeah. So, well, first of all, the EJ has a long history, right? It's got proven performance. It's been around since the 80s.
Yeah.
It's actually quite a simple design, right? But in addition to that, I've had 4 EJ cars. I've been an EJ diehard, so I don't actually have any FA parts at all.
Yeah.
But in addition, the FA has that large front timing cover, right? And that piece is so big, I wouldn't be able to 3D print that in one piece. True. And I think splitting that up into multiple pieces would just make things really messy. So the EJ doesn't have
Absolutely.
that. Yeah.
Yeah. And I just think it'd be a nightmare for oil leaks too.
Yeah. Yeah, man. I think that you know, as far as the FA version and stuff, I mean, if you start going into the boosted area, that may be a little bit different just because, you know, they are performing pretty well, and I think that people like them a lot. But at the same time, with the project that you're doing, it's a little bit off the chain, I would say. So
Yeah, the FA is definitely a better block. I will say that. But the thing is that doesn't really matter to me here because I'm designing my own, right?
yeah,
So I can take inspiration from the FA as well.
yeah, and I wanted to show this as well, which I think kind of gives a little bit of a window into this, is that people have already 3D printed fully functional, toy versions of an EJ, and with the full transmission behind it and the drive shaft and the rear wheels, like that, like the fact that this many parts have already been created and are functional, and it's just like it makes sense, right? I get what you're saying. There's so much data out there for the EJ, and it's such a simple design that like even people like this can just make toys for it, you know? Um, so I totally get what you're saying. I mean, this really seems like this is gonna be the best option for you. And I think that
Shut up and take my money.
yeah,
I want one of those.
yeah, Dave and I
I want one of those.
dude. So this
Super cool. And
this is
I just
what's
want to
crazy.
play with that in my room. Come on.
oh,
Dude, so Dave, this is what blows my mind about 3D printing, right? All of the files to make this are out there. Your buddy does 3D printing. You could literally just send him the files and he could just make this and you could put it together. Like, the STLs for this, I know, oh,
Caveat to that, I did ask him, and it's the time to do to put this entire thing together.
yeah.
There's still nuts and bolts and assembly. It's still building an EJ engine at the end of the day. And when I say I price it out, we're not talking hundreds of dollars. We're not talking tens of thousands either. We're talking in the thousands of dollars to build one of these to a certain level. And that's excluding the fact that I don't have the 3D printer. I mean, again, some of these files, and you can appreciate this, is the cost expenditure. Some of these aren't just available for free, and rightfully so. If someone spent 50 hours R&Ding something, maybe they don't want to put it on Thingiverse for free. Maybe they have to, recoup some of their time expenditure and they want to charge $5 a download on that file. And then what's really unfortunate as a creator and a designer, where you build something, you spend 200 hours building something.
Yeah.
And then you charge $5 a pop for someone to download that. And then you see someone who paid $5 selling your file for $25 a piece. And you go, is that stealing? Kind of. You're making more than I was charging for my exact intellectual property.
I mean, that's the same battle with tuning. People take tune files all the time and they make one adjustment and now it's their tune and they're distributing it. You know what I mean? Like that's like a horrible thing that has always,
which unfortunately I think we can make a cross comparison. It's not always right. When you take someone else's tune, if you reverse engineer someone's tune off their pro tune that you had on a dyno tune and and you put it on your access port for your car with the exact same year, make, and model, same parts, everything, it's not going to be right.
Yeah.
And the same thing goes for a 3D printing file. If you all of a sudden put in the same file, same specs, same 3D printing speed, same feed rate, whatever you want to call it, and it's not going to come out right, because guess what? You're using, as you mentioned earlier, a Bamboo Labs, whatever, $200 printer you got on Amazon. I'm sorry that your $200 Amazon printer does not compete with a $20,000 printer.
Yeah. And you know what? It's crazy too, from working in like Ford Performance with the tuning aspect of stuff, is like, it used to happen all the time. And realistically, at the end of the day, right? Unless you have a dyno, it's never really anybody's tune. Like you dealt with Whipple a bunch of time, and Whipple is huge on like they have an in-house tuner. They put out their own bass tune just to run the supercharger when you get it, but it's
Which
a
is a
rough
conservative tune. You have to consider it's a conservative tune.
And it's always kind of rough too. Like the shifting isn't perfect. It's literally just to get the supercharger running and to get the product out the door. And then whoever puts it on for you, who is a tuner, they take the file and they make it their own. And so like it is kind of like everybody's kind of using each other's files, and it's just one of those nightmare situations. But at the end of the day, like the STL files, if you put it out into the universe, right, like it is going to happen. Like people are going to find these files and they are going to try to make stuff, especially when it's that cool, like a running EJ that you could put in your room. You know what I mean? Like,
yeah. Just don't think you could do it with a $250 printer on Amazon. If just because you got those files for free, it's not going to come out right. Nothing's going to fit right. I mean, you get what you pay for, as the old saying goes, right?
Yep.
Niraj, I just wanted to show one last thing here, and then we're gonna start wrapping up. This is actually a 3D printed metal engine that was posted on Reddit here. It's such a crazy design. Let me a little bit closer.
That looks like metal 3D printing.
It is. So this is actually what's possible with 3D printing with metal. So, they kind of did a write-up and said that basically they printed several composites, full metal water jackets, or full water jackets with complete integrity, high resolution, final machining. It's just like essentially if you wanted to literally 3D print in metal, like this is what's possible. So, I think that because these expos are happening, these people are showing up with these things and they're getting the word out that this is a possibility. I mean, dude, imagine all these F1 cars, and the F1 cars that get totaled and they have to have all these engines on standby. Imagine if there was just one big 3D printer that they brought to F1 races, and you're like, we need another engine print.
It's going that way. It's going that way. I have no remorse in admitting that that's where things are going. Is 3D printing is the future.
Yeah.
It absolutely is.
Yeah.
Yeah. I think it's so crazy.
Well, we still need CNC machining for certain things. Arguably not.
Yeah.
When you can 3D print, I mean, if you're machining something down to a tolerance, maybe, but if we're talking about just production level, printing is going to be the new 3D printing, and 3D printing, I feel like and you guys can, I feel like, both appreciate, like it's a broad spectrum of a comment to say 3D printing. There's plastic 3D printing, there's metal 3D printing, like there's all different mediums. And you have to understand that like the future will be in 3 dimensions. The future is going to be able to produce things at a speed and a rate and a precision level that is unmatched to anything we've ever seen.
Yeah.
And that's what's coming. And I'm not saying to the detriment of any other manufacturing, but that's where things are going. Things are going to where we can produce things in multi-dimensions. Now we have, instead of a CNC machine cutting on one axis, even though that CNC machine could cut 20, 3 dimensions, it's cutting one axis at a time. Yeah, they have new machines now that can cut dual axis, what have you. But 3D printing is going to accelerate production and manufacturing on an unprecedented level, and I've long said that, and I believe it's beyond like people 3D printing some little boats.
Yeah.
I know the test boat that everyone prints. It's like that's not where 3D printing is capped at. That's the gateway, if you will.
I can say, like, I'm amazed at the amount of things that I order on Amazon and stuff now that come in there 3D printed. And it's like,
yeah,
that is like so crazy. Everything I order now, you see the lines and you're like, yep, I know exactly how this was made. It's like, but hey, you know what? It works and it's fast and it's efficient and who am I? you know, but Neeraj, I wanted to thank you for coming on, man. I mean, this has just been an amazing episode. I loved every second of this, and I was
Same.
looking forward to this
Me
all
too.
week. And as we do with every guest that comes on here, as we know, Dave has filled the Baja with canola oil. The Right now, the thought process is we're trying to get to 3,000 miles. And then he's going to check the oil, do the oil change, and we're going to kind of end the contest there. And we've had everybody take bets on at what mileage the car is going to blow up. And so if you're right, you're going to get a bunch of sponsor items and you're going to be able to be the winner. So you got to either get the right answer or the closest. So for context, it's a Baja, it's NA, it's got like 230K on it, and Dave is the driver. Just keep that in mind. So
Not just me. My employees drive that.
yeah.
And
sometimes
parking it today, I'm proud to say one of my employees, Jay, turned it properly, pulling it from the back of the shop to out front because we move things around in the day. And he properly J turned the thing 180 degrees around. And he looked at me dead in the eye. I was like, I'm impressed.
Yeah.
And so that's the kind of level of what this thing goes through. It's not 3,000 miles of straight abuse, but it gets abused.
Yeah.
Okay.
So what is your bet? How many miles? It's got like 250 on it now.
Yeah.
So what's your guess?
Am I allowed to say over 3,000?
So
No, it's 3,000, then we're going to change it.
Yeah.
Okay.
We're not going to keep going till it blows up. I mean, I feel like that's a futile, endeavor.
I think it'll make it to 3,000.
All right.
Okay. You're with me. I'm with you. Let's go. 3,000.
Yes, I agree. You know what? Have fun with that.
It's amazing that, like I told Dave before, if it does make it and the oil is clean and it hasn't consumed any, you're welcome. You're going to have the cheapest oil changes until this thing dies.
Right.
As long as you're not driving cross country for 3,000 miles, you'll be fine.
And
yeah, I'm not putting this thing on the track,
Well,
exactly. If you drive 100 to 200 miles a day, you'll be fine.
Well, Neeraj, what I've told Dave is I told him that for Boxer Fest this year, I wanted to fly out, get in the Baja, drive it to Boxer Fest in PA. It's like 1,700 miles. So if that, yeah. So I don't know.
We're still talking about it. We'll see.
That I think may be the nail in the coffin. But
I'm hoping my lead employee comes back by that point because he's been out, unfortunately, for some unfortunate medical issues. So if he can come back in the time frame here in the next foreseeable future, there's a very strong possibility that might happen because I've been humbly just trying to fly Patrick out here to Colorado for a while now. And if I have any excuse to get him out here for just a weekend before, and then we drive out to Boxer Fest together. And worst case scenario, we're sitting in the front seat of a Baja while it's on the back of a tow truck.
Yeah.
What you should do is just take that extra EJ engine you got and just throw it in the back.
Actually, you're right, because you're not wrong. I could probably bench press one of those in and just throw it in there. Let's go.
We got to know somebody in the route that would put that in for us.
That's right.
Good point. Good point. All right. We're gonna end it on this and say if anyone in the vicinity of Colorado to where we're going gives us an opportunity to stop by their shop if we blow up. mention it in the comments. Let us know, because we'll put you guys on the map and make sure we try to break down right about there.
I know the second we hit PA, people are gonna be offering us like, their shed in the back of their farms, with the engine hoist, So,
Good community.
yeah.
And I still humbly, for anyone who doesn't know, I'm originally from Philly, so I know some people in PA still. So I have to call in some favors. I can definitely find us a shop at. Don't worry.
Yeah. Neeraj, I can't thank you enough, man. This has been awesome. This is just such a cool concept. I think that you're gonna really get a lot of people excited just from this conversation. And I just want to have you, like, any advice for anybody that is getting into 3D printing, or is kind of trying to figure out how to get the STL files, put everything in, like is there any kind of advice that you have for like the process of getting into it?
How to learn CAD.
Yeah.
Humbly, I'm still trying to teach myself. It's slow. I'll tell you.
Well, I'll tell you the one thing is the first step is the hardest, right? Like we were talking earlier about my kit car, I've had to do everything on that car twice because I screwed it up the first time, and you just got to be okay with doing it wrong, that's part of the process sometimes. And it can give you a lot of anxiety because you're like, I know this is not going to work. You just got to do it. And you'll have fun along the way, which is the most important thing.
Great advice. I have done so many things wrong the first time. I can agree with that. So, but yeah, man. So definitely everybody out there, if you guys want, follow the 3D printing group on Facebook. You'll see Niraj posting on there. I'm sure some other crazy devices that he's printing and whatever else he's got going on. For you guys out there, check out our Instagram, Facebook page, check out Subaru Mechanics Facebook group. We are posting updates in there for the podcast as well. And then also the YouTube channel, amazing. Dave, we're almost at 1,500 subscribers. And that is like a feat, man. I mean, we're like 3 months in on this. So, I mean, clearly everything's been going great. So, we really appreciate it.
Everyone. Thank you to everyone.
Yeah, we're also on Spotify, Apple Podcasts, Amazon, Overcast, anywhere you get podcasts, you can find us. But definitely the YouTube channel's the best because we get the pictures and the visuals. So, this is Dave, Niraj,
and you get to see my shirts every week.
That too. So
every week a new shirt.
And we will see you guys Fridays at 7 a.m. That's when I'm trying to post all of the podcast episodes. So that's our new time frame, so you guys know when to catch us. And we will see you then.